Today, we would like to talk about how the company 3M could contribute to solving Asia air pollution through its product. First of all, we have to understand what is air pollution. In a polluted Asian city such as Beijing, the air is contaminated by a range of very different particles such as dust, pollen, smoke, and liquid droplets. These particles also come in many different size ranges such as coarse, fine, and ultrafine. Many of them can harm our health, especially very small particles that can enter deep into the lungs or even the bloodstreams. We sum up all of these solid and liquid particles and call it particulate matter, PM. Particles in air in Asian cities are either directly emitted, for instance, when fuel is burnt and when dust is carried by wind, or indirectly formed, when gaseous pollutants previously emitted to air turning into PM. Air pollution is killing 3.3 million people a year worldwide, according to Nature Journal, which is more than the number of people killed by HIV and malaria. Scientists from Harvard University said if the trend doesn't stop, by 2050, just 35 years later, the number will be doubled to 6.6 million each year. These are scary figures. Among all the areas that are greatly affected by air pollution problems, Asia is definitely on top of the list. Exposing to too much ambient air pollution has killed 1.4 million people in China each year, India with almost 0.7 million, and Pakistan with 110,000. We have to improve and ultimately solve this global problem, and clearly Asia, the most severe area in the entire world, is the first to start with. Therefore, our goal today is to substantially reduce the number of deaths and illnesses from outdoor particulate air pollution in Asian cities by 2030. We'll now look at how our organization, 3M, could contribute to a wider society goal. 3M is an American multinational conglomerate corporation. The company has 5 business segments such as industrial, healthcare, electronics products, and it also produces disposable respirators, air filters, and air monitors for consumer use. We will now move on to introduce the 2 products we think are important to contribute to the society goal, which are air masks and air filters. Currently, the technology gap of existing technology and ideal technology is that the technology we have nowadays allow a blockage of particles larger than 0.3 microns. However, we would like to develop technologies that can block ultra-fine particles, which is 0.1 microns or below, as this is the main concern, since it contains microscopic droplets that are so small enough to pass through the lung tissue into the bloodstream, causing death from respiratory and cardiovascular infections. Ultra-fine particle pollution poses serious health threats such as early death, strokes, asthma, cancer. Therefore, it is really important to develop technology which can block particles smaller than 0.1 microns. We'll now move on to talk about the existing 3M products. We'll first start with the air respirator. The existing 3M products which help prevent outdoor pollution is the N95 air mask. This is the most common and affordable mask that we can buy in the market. The retail price is $14 for a box of 10, $1.4 for each one. The current technology is that the mask is made up with 1 or 2 3M filters depending on the model of the mask. The image shows an enlarged filter. We can see that particles with larger diameters will be trapped shallower, more to the surface of the filter. Smaller particles are easier to pass the fiber, so they tend to be trapped deeper. 3M claimed that the respirator can block particulates which are larger than 0.3 microns. This means in an Asian city like Beijing, wearing a N95 air mask outdoor allows reducing respiratory illness by 12% and asthma for 19%. Also, the mask is said to last for 7 days. However, the test was done in a lab instead of real outdoor. Therefore, if the user is in Beijing, where PM 2.5 is as high as 46 461, the mask is unable to last for the life expectancy that that company has claimed. Also, N95 air mask only blocks particles larger than zero point 0.3 microns. Our focus today are blocking ultrafine particles, which are 0.1 microns, because they can directly enter humans' bloodstream, causing heart illness. So there is a technological gap between the existing technology and the ideal technology. We want to know if there are any companies working on this potential improvement of masks. We did a quick patent search and found one related company called Sterilitech, who is making polythiosulfone filter, which blocks particles ranging from 0.03 microns to 5 microns. If we can equip one of these filters onto an air mask, more than 90% of ultrafine particles can be blocked, since ultrafine particles are defined as PM 0.1, which is smaller in terms of its diameter. This can significantly reduce the chance of inducing heart and lung disease. However, the cost of each filter is $80, which is far more expensive than the existing masks. Therefore, the cost of delivering a more efficient air mask is the main concern at this stage. The air mask mentioned is focusing on outdoor pollution. However, according to the EPA, our indoor environment can be 2 to 5 times more toxic than our outdoor environment because contained areas enable potential pollutants to build up more than open spaces do. In some cases, the air measurements indoors have been found to be 100 times more polluted. Indoor air pollution is responsible for 2.7% of the global burden of disease. The sources of indoor air pollution are due to inadequate ventilation, tobacco smoke, mold, and household products. Nowadays, people spend 90% of their lives indoors and around 65% inside their homes in particular, and the average home contains about 10 gallons of synthetic chemical products. Most people may think that outdoor pollution is much more serious than indoor air pollution. However, this is not true, and it is a major concern to human health. As we can see, the disease burden due to indoor air pollution is higher than outdoor air pollution around the world, while Latin America is the only exception. Even in China, the world factory, the disease burden due to outdoor air pollution is not higher than indoor, but just the same. This implies that indoor air pollution is actually a more severe problem than outdoor air pollution. To solve indoor air pollution, we could install portable filters to filtrate particulates. We currently have HEPA filters nowadays, which can filter up to 0.3 microns. However, HEPA filters cannot remove gases and smells. Multi-stage filters was developed with pre-filter to capture larger dust so that HEPA filters will not be worn out so quickly, and current absorber to absorb odors, and electrostatic ionization to improve effectiveness. However, as mentioned before, the main concern with air pollution is the ultrafine particles, which are 0.1 microns or below. There is once again a technology gap in this case, as the HEPA filters has not got the ability to filtrate 0.1 microns or below. Currently, there is an emerging technology which is the photocatalytic oxidation developed by NASA. It has the ability to destroy toxic gases and ultrafine particles up to 0.01 microns into safer compounds such as H2O. We can now look at all the patents in current space. Some of the key players in producing HEPA multi-stage filters are Blue Air and Honeywell, and the only companies doing HEPA and photocatalyst filters are Amicare and Hoover. And we have the filterless photocatalyst units developed by Aerosite and Air Oasis. Let's now look at how effective and efficient they are to see whether the technology is worth developing and actually solve the problem. Photocatalytic oxidation is definitely an area to look at, as it closes the technology gap by filtering 0.1 particulates. But we can see that the limitations are it will consume more power and the rate of cleaning air is slow compared to the HEPA filter. However, the price is relatively cheaper. The reason behind is that since photocatalyst is a new technology, big companies haven't integrated technologies in their products. Therefore, the currently existing products are developed by startups focusing on only photocatalytic technology instead of the overall filter performance. We'll now look at the impact of the new technologies to see whether it is worth developing and investing. According to the World Health Organization in 2008, the number of deaths due to air pollution are as follows, and if we divide capital by death, we get the death rate. We can see that the majority of them are from developing countries. People from developing countries will not afford a high-quality HEPA multi-stage filter as it is way too expensive and hard to maintain since you need to constantly replace filters, especially if you are living in the busiest part of the city. Recalling from previous table, a multi-stage HEPA filter costs $2,300 and a base cost of $1,099 plus $60. If we look at the most severe countries such as China, India, and Pakistan, the household consumption expenditure per capita is around $1,000. Therefore, it is not possible for them to afford the multi-stage HEPA filter, nor will they afford an $80 disposable face mask for the filtration of 0.1 microns particulates. However, research said that HEPA filters attached to a fan is as efficient as expensive models. It only costs $30 to get DIY HEPA filters. Therefore, it might be possible to infuse photocatalyst onto HEPA filters and sell it as a single unit instead of on an air purifier machine. So the question is, should we invest on developing polysulfone filter for face masks and photocatalyst HEPA filters for residential air purifiers? The current issue is that particulates smaller than 0.3 microns are causing death in Asia. If we assume air outside particle concentrations are about 1 million 0.5 microns and larger particles, it will not be an unreasonable assumption as levels are much higher in many areas of the country. In this case, the number of 0.1 micron particles will be about 35 times as many as for the 0.5 micron particles, or about 35 million particles per cubic foot. Now, let us assume we are using a 99.999% efficient HEPA filter. We would filter out 34 million particles, but 350 0.1 micron particles would remain. China is an intense hotspot of traffic and transportation, therefore the amount of diesel exhaust will be higher, resulting in more than 350 0.1 microns particulates. 0.1 particles are the main cause of death from air pollution, as smaller particles can be inhaled deeper into the lungs. If we are able to filter 0.1 microns particles with advanced technology mentioned in this presentation, the average country life expectancy will increase as air pollution is cutting life expectancy by 5.5 years in China. Therefore, we should definitely invest to develop products that can filtrate particles up to 0.1 microns to save lives.